Hey guys, in this video I'm going to teach you how to solve radical equations. So at the top of page 42 in your notebook there are 4 steps to solving radical equations. The first step is to isolate the radical symbol using inverse operations. So basically what that means is I want you to pretend that the radical is a big giant variable itself and you want to get rid of anything in front of it and anything behind it that is not underneath the radical. Then, to get rid of the radical, you got to square both sides, because remember, squaring is the opposite of taking the square root. Once you have done that, you want to solve for x, and then you can always check your answer, but remember, we can never have a negative square root. Okay, number 1. If we look, you see that we have the square root of x is equal to 12. There's nothing in front of the radical and nothing behind the radical, which means the radical is already by itself, so we can skip step 1. So we need to get rid of the radical. Well, remember, the opposite of the square root is to square things, so we got to square both sides of the equation. When I do that, the radical goes away and the x underneath stays exactly the same. It's important to remember that when you square a radical, the stuff inside stays the same. 12 squared is 144. So that's it. That would be the answer for number 1. X is 144. Now, if we wanted to check our answer, all we would have to do is take 144 and substitute it back in for x. So that would give me the square root of 144 equals 12. And the way that we know that this is true is that we would get the exact same number on both sides. So if you took your calculator and put second x squared and put in 144, if it says 12, that means we did it correctly. And it does in fact say 12. So we get 12 equals 12, which means this is a true statement. Now you don't have to do that step for every single problem. It's just a good way for you to check to make sure you got it right. All right, number 2. We have radicals on both sides of the equation. So for Algebra 1, we're never going to give you anything more complicated than this. So if you see a radical on both sides of the equation, your first step is to automatically square both sides. You won't have to do anything else. That means the radicals are going to go away in both cases and everything else stays the same. So 3x minus 8 equals 2x plus 14. So now it just becomes an equation with variables on both sides. And you guys have done this before. I like to get all the variables on the left and all the constants on the right. So for that reason, I'm going to subtract the 2x over to this side first. You could do other steps first, but that's just what I'm choosing. 3x minus 2x is 1x, or x. Bring down the minus 8, and that's equal to 14. The last step is to add 8, and I'm going to get x is 22. 22. All right, so let's check that answer. I'm going to plug 22 in for each x, so I'm going to have the square root of 3 times 22 minus 8 equals the square root of 2 times 22 plus 14. So for these, what we're going to want to do is just plug in the stuff underneath the radical, and we just want to make sure that we get the same radical. So 3 times 22 minus 8 is 58, so I get radical 58, the equal sign. And then 2 times 22 plus 14 is also 58. So I get radical 58 equals radical 58, which is the same thing, so that is correct. All right, number 13. So if you take a look here, there is something in front of the radical. So when I'm talking about in front of the radical, I mean things not underneath the radical. This is the radical right here, the square root of 2x plus 6. That means I got to get rid of the 12. The 12 is positive, so the opposite would be to subtract it. So subtract 12 on both sides. I'm now going to have the square root of 2x plus 6, and it's going to be equal to 6. The radical is now by itself, so I can square both sides. So now I'm going to have 2x plus 6 equals 36, because 6 squared is 36. The next step would be to subtract 6, which is going to give me 2x equals 30. I'm going to rewrite that up here because I've run out of space. Then finally, divide by 2, and you get x equals 15. All right, let's check that answer. So we have 12 plus the square root of 2 times 15 plus 6 equals 18. So I want this whole side to be 18. So let's go ahead and plug that straight into our calculator. 12 plus second x squared 2 times 15 plus 6. I get 18. So 18 equals 18, and that is true, which is what I want. All right, number 4. Again, here is the radical, the square root of x plus 4, which means I got to get rid of the negative 3. Now, a number right in front of a radical still means multiplication, so the opposite of that is to divide. Divide both sides by negative 3. I'm going to get 6 equals, the square root of x plus 4. So now the radical is all by itself. Square both sides, and I'm going to get 36 equals x plus 4. And your last step is to subtract the 4, so you're going to get x equals 32. All right, let's double check that answer. Negative 18 equals negative 3 radical 32 plus 4. So let's take the calculator and plug this side in. Negative 3 second x squared 32 plus 4, and I get negative 18. So I get negative 18 equals negative 18, which is a true statement, which means I have the right answer. All right, number 5. Again, the radical is right here. It's radical x minus 3 equals 10. Now, there's something special about this one, but I'll show you what I mean here in a minute. Let's get the radical by itself, which means I got to get rid of the 5. The opposite is to divide. Divide by 5. And I'm going to get the square root of x minus 3 is negative 2. Now remember what it said here. We can never have a negative square root. So if you look here, right now I have the square root of x minus 3 equals negative 2. When you think about taking the square root of numbers, you're never ever going to get a negative number. So this is actually impossible. But I'm going to keep going just to show you that you could get an answer and that it's very important for you to be careful when you're solving these types of problems. So if I square both sides, because that's what I would do to get rid of the radical, I would get x minus 3 equals 4. Because remember, this is technically in parentheses here. So I'm going to add the 3. And I would get x is 7. But look what happens when I go to check my answer. I'm going to get 5 square root 7 minus 3 equals negative 10. When I plug that in, 5 second x squared, 7 minus 3, I get positive 10. So I get 10 equals negative 10, which is not true. So that means x equals 7 is not the correct answer. So here's what I want to point out to you. Whenever you get to this step right here, we had radical x minus 3 equals negative 2. If that happens, and you get a radical by itself, and it's equal to a negative, your answer is automatically no solution. It's very important that you realize that when you get to this step, because you can get an answer, but it's not correct. All right, so anytime the radical ends up by itself and you have it equal to a negative number, it's equal, or it is no solution. But I want to point out this one here, it's equal to a negative here, but the radical was not by itself yet. So it's important to make sure that you get the radical by itself before you determine that it's no solution. And that's it. That is how you solve radical equations.